Then today we are going to discuss about voltage drop calculation using Etap software, and also we will be discussing about short circuit current calculation using this Etap software. Okay. So how to make the short circuit calculation and how to do the voltage drop analysis, let us do now. So like I have opened a new sheet. You can see here edit mode. So this is the worksheet. So here we are going to prepare a single line diagram, and this one is load flow analysis, right? So for calculating our short circuit current, we need to change that mode to this short circuit mode. Okay. So these all are different modes. Yesterday I have told you, like this is called, this specific menu bar is called as mode toolbar. Okay, mode toolbar, because we are having a number of different modes here in this toolbar. Okay. So anyway, I am going to make the single line diagram, right? So I am going to make a single line diagram different from yesterday's, right? So we are having a number of projects, right? So like in electrical section, in our design classes, we have discussed about a number of projects, like different projects I have referred there for different applications or the parts, right? Okay. So like we are having, you may be familiar with this drawing, like UAE project. Its schematic diagram. This is not the one, like I'll show you. This one, right? This one, and electrical drawings for the power layout, schematic diagram. Like this LV panels, low voltage panels. Here you can see we are having different loads or SMDBs which are connected from this MDB, right? It is a LV panel 1, it is LV panel 2. From here, it is a transformer, it is LV panel or MDB. Then from there, different loads. Here, different SMDBs are connected, right? Different SMDBs are being connected with different loads. Load is written in kilowatts, right? 147.2 kilowatt, 138.1 kilowatt, 147.2 kilowatt, like that, right? Suppose I am getting like an MDB like this. I need to select each of that circuit breakers, its fault current value, etc., right? So like for selecting these isolators, fuses, circuit breakers, etc., and also cables, we need to do the short circuit current calculation. So why we are doing short circuit current calculation? Because we need to calculate the short circuit, because all these protective equipments we are using for getting protection against this short circuit current, right? So at that time, we need to conduct the short circuit current calculation. So at this junction, how much short circuit is possible? At this cable, how much short circuit is possible? Like that. Okay. So by calculating that short circuit, let us analyze, like let us select the circuit breaker, fuses, and other protective devices, then cables, etc. Okay. So that is why I'm going to do the short circuit current calculation. Okay. So load flow analysis, what is the relevance? Already I have discussed to you. Then this is the relevance of short circuit current calculation. We are calculating the short circuit of a power system at various points for selecting various elements like protective elements like our circuit breaker, fuse, etc. Then relays. Then the value, setting value of relay. etc. Then cable selection, etc. Okay. So I'm selecting. First, I'm going to make a single line diagram. Before that, we are having different faults, right? So fault current calculation also we have done with the HT side of the transformer. So in our previous class, you can check with LT side calculation and HT side calculation. After instrument transformer class, we have discussed about the LT side of transformer and HT side of transformer. Okay. So at that time, we have calculated the fault current there, right? How to calculate the fault current? Fault MVA divided by √3 into voltage. By that equation, we have calculated the fault current there. At that time, I have told you here fault means short circuit, right? So short circuit. So what are the different faults actually possible with our transmission or distribution system? So different faults are possible, right? So especially when we are considering the primary side or secondary side of the transformer, different types of faults can be possible there. So like we are having in a three-phase system, we are having three phases and neutral, right? That is L1, L2, L3 and ground. So in between this L1 and L2, short circuit can happen. Then in between L2 and L3, short circuit can happen. In between L1 and L3, short circuit can happen. Okay, so that is one type of short circuit. Otherwise, in between L1, L2, L3 and ground, short circuit can happen. In between L1 and ground, short circuit can happen. L2 and ground also it can happen. L3 and ground also it can happen. Then also in between L1, L2 and ground or L2, L3 and ground. Like that also fault can happen. Okay. So line to line to line to ground, right? Line to ground. Then two line to ground, one line to ground. Then in between lines also, in between these three lines also, fault is possible, right? Okay, so that are different types of faults. They are also called as symmetrical fault and asymmetrical faults. Okay, two types of faults, symmetrical faults and asymmetrical type of faults. Okay, then what is the possible reasons behind this fault or short circuit? So most probably it will be by insulation failure, right? Insulation failure. So in the basic class of electrical, we have discussed with insulation failure, right? So why we are getting a shock? Like in a simple case, why we are getting a shock from an electrical equipment? That may be due to the insulation failure. So when if we are having a non-current carrying metal frame for an electrical equipment, generally it will not be carrying. Under normal circumstances, it will not be carrying current, right? But due to any insulation failure happening inside that equipment, that non-current carrying metallic frame also will be carrying current because metal is conductor, right? Okay. So insulation failure is a reason there, right? Okay. So insulation failure is one of the reasons behind this short circuit. Okay. Then second one is like, in our distribution line, sometimes we will be losing we will lose the power, right? So several times in our state or in our country, we'll be getting power failure, right? So especially during rain or something, rainy season, a number of times we will be losing power. So why? That is the temporary loss actually, right? It is happening due to some temporary obstructions, right? Like some trees are filling, like that. That are temporary cause of interruption for the fault current, or it is possible for short circuiting also. Okay. So then another one is like, lightning strikes. When lightning strikes are happening, then also like short circuit is possible there, right? Okay. So these are the common causes of short circuiting, like insulation failure, then like some trees or any obstructions will be causing some short circuit due to lightning strikes also. Okay. So these are the common causes for happening this short circuit, right? Okay. So we want to analyze or we want to calculate this short circuit. Okay. Now I need a single line diagram for my power system. So for analyzing or for calculating the short circuit current. So like this, as an example, like this, we will be making a single line diagram like with a transformer. So this transformer is actually connected from like if it is a DEVA project, like it is in UAE project, then it will be most probably it will be receiving power from like DEVA, right? DEVA or ADDC, etc. Okay. So this one is getting power from DEVA. Okay. So from supplying authority to the transformer, then from the transformer to this main distribution board or LV panel, low voltage panel, then from that main distribution board bus bar to the sub main distribution boards. Okay, sub main distribution board. Otherwise, like if you are checking the single line diagram of SMDB, so I am going to the single line diagram of SMDB. Here is one SMDB. Okay. It is a single line diagram of an SMDB, right? SMDB. Okay, so it is feeding from LV panel or MDB1. Okay, then SMDB, like, see, SMDB1, FB1, FB2 to SMDB3, FB2. It is feeding from LV, low voltage, MDB1. Okay, so it is getting power. Then there is circuit breaker MCCB is there. Then here you can see like bus bar is there. Then it is connected to a number of connections are going to individual dBs, final dBs, final dBs. Okay, so here we are getting power from LV panel or MDB, main distribution board, right? Main distribution board. Then this is SMDB. Then from SMDB, power is distributed to final dBs, right? Suppose you are getting such a single line diagram. You want to calculate the short circuit current of such a system. How to do that? So I am just checking this one, right? MDB. So from the transformer to the MDB, then to the SMDB. It's like that. Okay. So anyway, I'll be creating a single line diagram in Etap. So first I am taking the power grid, right? Power grid. Power grid. Then either you can double click here and add the parameters now. Otherwise, after forming the entire single line diagram, you can add the parameters. Okay. Then from this power grid, I need a bus here, right? So I'm selecting a bus and placing a bus here. Okay. Then after that, I need a transformer. Okay, I need a transformer here. So I'm placing a transformer. Okay, then again, I need a bus over here. Then I need from this transformer, I'm going to connect like a number of between that. This is at the secondary side of transformer. Okay, so here I need a secondary cable, right? So in our single line diagram, previous class, I will show you. That instrumentation transformer, this one, instrument transformer. Okay. It is a secondary side of the transformer, right? Secondary side of the transformer. And this is the primary side of the transformer. Okay. So from the secondary side, we are having a LT cable, right? There is an LT cable, AYFI cable that we are using. And at the primary side, we are having another cable. Okay. So here, I need a cable for connecting from the secondary side, right? So I am selecting a cable from here, cable, placing the cable in between the transformer and the bus over here. Then I need to increase the size of this bus because I need to add. Just click there, go to the end of the bus, select the bus. Okay, go to the end of the bus. Okay, there you will be getting extension option. Okay, you can extend here. Just stretch and extend it. Then I need a number of cables. So if you want to use any element from this element toolbar multiple times, then just double click here. Okay, then I'm adding 1, 2, 3, 4. Okay. Then I need some lumped loads, right? Lumped load. Okay. Then adding loads. I'm adding some loads here. Okay. Okay. And after that, I'm going to connect them. Select it. Then from here, you may connect that to the bus. Again, from here, connect, 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 connecting, connecting. Okay. So I have connected all the elements here, right? Yes. So there's a power grid, a bus, then there's a transformer. Here also we are having a bus. Okay. So here bus number 3, you can see like a small red dot can be seen here because I have not attached bus here. Anyway, we need a bus. Okay, whether we are attaching bus directly or we are not attaching it, a bus will be formed at this junction. Okay, so already we are having a bus here. I have not attached or I have not included a bus over here, but already it has created, right? Okay, so I'm selecting here. Yesterday I have shown you how to place the bus, right? Place the bus. So here all we have placed the bus in yesterday's single line diagram. Here I just missed to place the bus over here and here also. But see, bus is already created here and at all the missed points. Okay. So I'm selecting that bus. Then just right click here. You will be seeing there an option, bus or node. Now that bus is formed like a node here, right? A small dot can be visible here. Red color dot. Okay, just right click. Then bus or node option. Turn on the bus. You can also represent that as a node. Okay, that is the representation now. Okay, I need to change that node to bus like this. Bus number 1. So I'm changing that to bus. See, now you can see that bus over here. Same like I'm repeating here also. Here also I need bus, right? Already buses are there, right? Automatically created, but I need to replace this node with bus. Okay, select the bus 4, then right click here. You will be getting bus or node. Select this. Again, select bus number 5, right click. Then bus or node, bus. Bus 6, bus or node. Bus 7, right click at that node, bus or node, bus. Okay. So power grid, bus 1. Then we are having bus 2 over here, bus 3 over here, 4, 5, 6, 7. Then transformer, cable, then cables, lumped loads, 4 numbers of lumped loads. 4 numbers of cables here also. Right. Okay. So in this format, we are having our MDB connection, right? From the secondary side of the transformer, like we need to place a circuit breaker here, right? But before selecting the circuit breaker, we need to calculate the short circuit. That is what we are going to conduct now. Okay. Okay, so like that, now I am going to add parameters to each of my components. Yesterday, the same thing we have done, right? So I'm selecting that power grid. Then info, I'm naming that as power grid. Okay, then it is connected to bus 1. Okay, then connection 3-phase. Then we are going to rating option. A rated kilovolt, I'm giving like 11 kilovolt, right? 11 kV I need for my transformer. Then going to the short circuit. Then also It is balanced. I am selecting this as balanced. You may also select unbalanced. Here I am having a balanced power grid. Okay, so I'm selecting this short circuit. Then it's short circuit current rating. Like I have explained in yesterday's class already in the HT and LT panel side calculation. The HT panel side calculation, this short circuit current calculation already we have done. Okay, so we know 250 MVA I am considering because here we are having 11 kV as the rated voltage. Then X by R, ratio of reactance to resistance. Okay, so like ratio of reactance to resistance. Actually, these values will be available from our supplying authority, right? Okay, so this value fault MVA and X by R ratio will be available from our power system or the power supplying authority only, right? So here I am considering some 5% or 5 X by R ratio I am considering like 5. Then you can see here fault current is calculated. How much it is? 13.122. Okay. Short circuit current or fault current at 11 kV with 250 MVA fault MVA. Fault current is 13.122. Same current there also. You can refer that class. You will be getting the same current there. Okay. Okay. So the information, I have changed the name power grid. Then going to that connection 3-phase rating, 11 kV balanced, short circuit. I have provided 250 MVA X by R. I have provided 5. Okay. Then giving OK. Now I'm going to, now you can see like power grid and 250 MVA fault MVA shown on the screen with the single line diagram. Okay. It is shown with a single line diagram. Now I'm selecting the transformer. Okay. Transformer T1. So I'm keeping that same name T1. It is connected from bus 1 to bus 3, in between bus 1 and bus 3, correct? Then here I need to go to the rating. See the voltage rating at primary side, how much it is? 11 kV. Secondary, how much? Yesterday I have provided 433 volt. That is 0.433. We are having 11 kV bar 433 volt distribution transformer with the same power rating that we have used in the HT panel sizing. I am using here too. So like whatever is your transformer rating, that can be included here. Okay, just click here. It will be changing in between MVA, VA and KVA. It will be switching in between MVA, KVA and VA. So I am going to include that 500 kVA. I'm having a 500 kVA, 11 kV bar 433 volt distribution transformer that we have used in the same HT side calculation in the design classes. Okay. Okay, then I'm going to my impedance option. Impedance. I don't know the percentage impedance X by R ratio, etc. of my transformer. If you know, suppose I am having like 5%, that can be included, right? That can be included. But if I don't know, this will be available with the nameplate of the transformer. So the exact percentage impedance, X by R, etc. will be available with the data sheet or with the nameplate of the transformer. Okay, I don't have the nameplate now, right? So I am setting typical Z and X by R. Okay, it is a typical values of impedance, percentage impedance and X by R. Okay, 4 and 1.5, that the same I am keeping here. Okay, then not anything I need to add more. So I'm giving okay. Info, rating, impedance. Okay. Okay, so I hope you remember these values, rating. See, when I have entered that primary and secondary voltage, full load current at the primary side. See, this the same value we got in that primary side calculation of transformer. Okay, then secondary calculation, secondary current also we got here, right? Okay. Yes. So the secondary current either you can achieve from that manual calculation. Otherwise, like I have shown you that electrical data book, right? From the electrical data book also that will be available. from our electrical data book. See from page number 5. See, based on the capacity of transformer 11 kV bar 433 volt, we are getting that secondary current, right? 500 kVA 666. If we are using manual calculation, at that time we have used this equation 1.33 into load in kilowatt. Okay. And using Etap, we are getting that value 666.7. Okay. Okay. So that's it. I'm giving okay here. Now I'm going to the cable. I need to select the cable. See, now the bus is shown like 11 kV, 0.433 kilowatt. Now I'm selecting the cable. Then from here, you'll be getting, say, like info cable 1. Okay, so I'm keeping that as cable number 1 itself. Okay. Otherwise, I'll be giving a short code, short name, L1. Okay. From L1 is connected from bus 3 to bus 2, bus 3 to bus 2, right? Bus 3 to bus 2. Bus 3 is also at 4.433 kilowatt. Bus 2 is also at 0.433 kilowatt. Okay. Then I need to select the length of the cable, right? So I am from this transformer secondary side to the bus bar. I am giving like 10 meter. Okay. Meter. Then I need to select the size of the cable, right? Library, from library. See, I'm selecting from the transformer secondary side. So based on our fault current calculation, we have selected some size of cable, right? I think it is about 400 mm square cable. Let me check it. At the secondary side of cable, yes, 3 into 400 mm square or 4 into 240 mm square. Okay. So I'm going to select the same cable from here. Which type of cable it was? It was AYFI cable, right? So AYFI cable 3 into 400 mm square or 4 into 240 mm square. Okay. So it is aluminum, right? AYFI means aluminum conductor. Type, not copper. I need aluminum only. Okay. All these are aluminum cables. What is the voltage we need? 0.433 kV is our voltage, rated voltage. So I need a voltage greater than this. Okay. So we are having greater than 0.433 kilowatt, that is 0.61, etc. Right. Out of them, I am selecting like unit. Unit I need in metric, not English. Okay. Okay. Now the frequency has changed. In English system, it is 60 Hertz. We need 50 Hertz in metric system, metric unit. Okay. Then type of cable, aluminum. Voltage is given here. Class, it is class, percentage class. Then number of cores are given here. Then insulation type is given here. Insulation, see, you are having rubber insulation, XLP insulation. Okay, like that. Okay, so I'm selecting 50 Hertz metric, aluminum 0.6 kilowatt, class 100, 3-core rubber insulated. Then size 400, right? So I'm selecting this 400. Okay, giving okay. Yes, I can also give some tolerance here. I'm giving some 2%. Okay. Then going to the physical impedance. Okay. Once we are selected that once we are selecting that size of cable, these values I think already they are set. Okay. Giving okay. Then going to select the next cables one by one. Cable number 2, same info L2 from bus 2 to bus 4. Okay, then length. I'm giving some 5 meter length. 5 meter length. Then from the library, I need to select the size of cable, but here first I need to add the parameters for the lumped load, right? Because from the connected load only we can calculate the load current, right? So if we know the load current, then only we can select the size of the cable. Okay, so first I will be selecting the lumped load. After that, based on the load current, I will be selecting the cable. Okay, so I'm going to select that lumped load 1. Okay, lumped 1. So I'm giving like load 1. So in load 1, what is our load? Nameplate. MVA I'm changing, VA kVA. So I'm connecting some 20 kVA. I have a 20 kVA. You can also include that in kilowatt. Suppose I'm having 20 kilowatt. You can include that. Okay. So it will become 22.61. Okay. So if you are getting that connector load in kilowatt, then you can enter the kilowatt format. Kilowatt load in kilowatt. So it is 20 kilowatt, then corresponding kVA value will be 22.61. If you want to change the percentage power factor here, now it is 88.47. Suppose I am changing it as 80. How much it is? Kilowatt, again I'm changing 20. Okay. First of all, I'm just making 0 here. Kilowatt I'm adding. Power factor I'm adding 80. Kilowatt I'm adding 20. Okay. Now all the values have been changed, right? Then if I'm changing that power factor 80, see again all the values are changed, right? Okay. So here again I am adding like 20. Okay, so then other values will be changed. Okay, so better I am entering that in kVA, right? So I am adding like 20 kVA. Then power factor 8. Okay. Then 20 kVA, kilowatt 16, kVAR 12. Then percentage power factor 80, ampere value this much. Okay. So you are getting this much current value, right? This much current value, 26.67. So if I'm having 26.67, not any other value I need to enter here. I am giving OK. 26.67 is my calculated current value. Based on that, I can select the circuit breaker, MCB or MCCB. Its rated current value I can select. For the fault current selection, I need to calculate the fault current or short circuit, right? Okay. Anyway, I got that full load current value as 26.6, right? So from here, 26.6 into 1.2, 31.92. This is the size of cable that I need to select. 31.92 based on this current carrying capacity. Okay, this is the current carrying capacity. So if I am going to that table, 31.92. AYFI cable size we are having. Page number 4. Page number 4. See, current rating of AYFI cables. So I need how much? 31.92. Nearest value 35 mm square, right? So I need 6 mm square of aluminum cable, right? 6 mm square. So I am going to select, it is a AYFI cable. There the type or insulation may be changing, but the conductor is the same. That is why I am selecting from this table, right? So anyway, which cable you are using, you will be getting the catalog from that manufacturer. Okay, which manufacturers or which make cable you are using, you will be getting the catalog from that manufacturer. It will be having a table like this, current rating and mm square area of conductor. From the same table, you need to select the cable size. Okay, here as I got how much value? 31 point something, nearest to current carrying capacity 35. I am selecting 6 mm square AYFI cable. Okay, so here I am going to select my cable now. cable 2 or it is L2 now. Then length I'm giving like 20 meter. Okay, 20 meter. Then selecting from the library. Frequency I have changed already. Type aluminum cable only. Okay, conductor. Then insulation rubber only is available. Then this cable with how much size? I just forgot it. 35, 6 mm square. So I'm selecting 6 mm square cable. Size is different here, right? So like it will be like metric. Unit is metric. I'm changing metric. Okay. Okay. Now the size is available in mm square. Okay. 50 aluminum, 0.6 rubber, 3 core. Okay. 6 mm square. Giving okay. Okay. Then going to the physical option, impedance option. Okay. So cable 1 is selected. Cable, which one it is? Cable number 2, right? Then again, lump load, second lump load. Load 2. Going to the nameplate itself. Connected load is 25 kV. Okay. Power factor 80. Okay. Then short circuit. Okay. So what is the current there? I have not noticed it. Nameplate. Current is 33.33. Again, 33.33 into 1.2. How much it is? 39.996. Take the table, 39.996. 46. Next size is 10 mm square. Nearest value to 39 point something is 46. It is greater than 35, less than 46, right? So current carrying capacity 46 ampere. Cable size is 10 mm square. I am going to Etap now. Giving OK. Cable L3 10 meter. From library. Same cable. Unit metric. Mm square. Same this one, right? XLP, PVC cable is available. Here copper, right? So I'm changing that to aluminum. I need aluminum cables only. Okay. Aluminum cable. Frequency unit I'm changing from metric, English to metric. Okay. Same cable, this one. Then 10 mm square. Okay. Tolerance 2%. Okay. Then here I am selecting lumped load 3. L load 3. Nameplate. KVA value 30. Power factor 80. How much is the current value? 40 ampere. 40 ampere. 40 into 1.2. How much it is? 48 ampere. 48 ampere. Nearest value 48. 16 mm square, right? 48, 46. Okay, it will be better if I am selecting more size. 16 mm square. Going to Etap. Cable L4. 5 meter. Unit metric, frequency, type I'm selecting to aluminum. Okay. Unit changer, selecting metric. Okay. Same type of cable. I'm selecting 16 mm square. Okay. Tolerance 2%. Okay. Then lumped load 4. Load 4. Nameplate 50 kVA. 80% power factor 0.8. Current is 66.67 ampere. 66.67 ampere. And with that current, 1.2 into 66.67, 80 ampere is the current. 80 ampere I need to select, greater than 76, 35 mm square, right? 35 mm square. Okay, L5. Aluminium. $35 square. Number of conductors per phase, all 1, right? So for all the cable, it is like that. I'm selecting, okay. Now all the parameters I have added, right? All the parameters have been added. Now I'm going to calculate the fault current. So for calculating the fault current, first we need to change the mode to short circuit mode. So I'm changing the mode to short circuit mode, which is near to my load flow analysis mode. Selecting short circuit mode. Okay. Now you will be getting different element toolbar here, right? Okay. So this one is running 3-phase device duty. That is like if you are conducting this one, you will be getting line to line to line to ground, line to ground fault, 3 line to ground fault. If you're selecting this one, then you will be getting other like another type, line to ground, line to line, like that. All the faults you will be getting by this option. Okay, so from the symbol, you can understand that 3-phase to ground or 3-line to ground fault can be run by this option. Another faults like line to line to ground, 2-line to ground, etc. can be run with the second option. Okay. Sorry, not this one, right? This one. This is line to ground, line to line, 2-line to ground, 3-phase faults, etc. Okay. So here I am going to run 3-phase, this one. Okay. So before that, I need to do one thing. I need to select the bus to which I need to calculate the fault current. Okay. See, I am selecting the bus over here. Right click, select fault. Okay. Select the bus, right click, select fault. Then you can run that fault. This. Give a name for your file. SC1 I am giving. Okay. So you can see the fault current here. Fault current. Okay, at this bar, fault current calculation has been done. And this is the fault current result, 13.153 kiloampere. Again, I am changing that mode to edit mode. Selecting the next bus. Right click. Selecting the bus, right click, and I can activate the fault option, but it is not showing here, right? Selecting this one. Because I need to activate the short circuit, right? So I'm changing that to short circuit mode. Then I'm selecting this bus, right click. Now you can see their fault. Okay, so this bus also I need to calculate the fault. So I'm activating that fault current. See, this much is the fault current here. 17.828 kiloampere. Okay. Then suppose after changing this, I'm going to edit mode. Then I'm going to my fault mode. Then I'm running this one. Line ground, line to ground, line to line, etc. I'll be getting. See, like this. Okay, like this I'll be getting the current. Okay. Okay, so again I'm going to change that to edit mode. Now, if you want to add anything here, you can add that. Otherwise, see, all the buses can be selected and you can run that fault current calculation. Okay, so I'm going to select the remaining buses also. Then I will be conducting that fault current calculation option. Either you can select the bus, then right click, then select the fault option. Otherwise, after changing that to the short circuit mode, okay, we can change that from the short circuit mode to load flow mode or edit mode. Just go to here, edit mode. It will be changed to the previous one, right? If you want to calculate the short circuit, then you need to change to short circuit mode. After that, either select right click, select the fault option. Otherwise, here you can see like edit study case option is there, edit study case. For example, I am selecting this bus bar. Okay. Edit study case option is there. From here also we can select which bus we need to calculate. Which bus you need to select here. Okay, that bus can be selected from here also. Okay, so these two buses already I have calculated fault current. Now I am selecting this bus. Right click. Okay, right click and I'm going to change fault. Then running that fault current calculation. See, already these two buses are faulted, right? Fault current has been calculated at bus number 1 and bus number 3. Then bus number 2, we can see that fault current. Same like I am selecting bus number 4. Right click. See, the option is available here for getting our output results. Okay. And from here also you can select that report manager for getting the output. So after calculating all the fault currents, I will be taking from here report. Right click, fault option, selecting, right click, fault option, selecting here, right click, fault option. Here also I'm selecting right click, fault. Okay, now I'm running that fault. Okay, it is the short circuit current at each node or each bus, you can see it. .113 kiloampere, 5.743 kiloampere, 10.985 kiloampere, 13.599 kiloampere based on our connected load voltage, etc. Here 16.574 kiloampere, 17.828 kiloampere, 13.153 kiloampere. These are the short circuit current values. Then if you want to see it more clearly, you may zoom it. Okay. So fault current calculated at each bus will be available here. Based on this value, you can select. For example, I am selecting circuit breaker for this load 1 here. So I can select based on this fault current value. Rated current value we are selecting based on the connected load, right? Rated current, rated ampere or ampere rating. Fault current rating we are selecting based on this value. Okay. Okay, so this is our fault current calculation. Now I need to generate report for this fault current calculation. I need to generate the report here. Okay. So I'm selecting and going to generate the report. So here is an option, report manager. Here also we are having report manager option. Selecting report manager, I need the summary in PDF format. Giving OK. As for report manager, selecting that result, short circuit report, result, short circuit report in PDF format, giving OK. Okay. Okay, so this is short circuit report. Short circuit report. It is having different pages like voltage and initial symmetrical current. You will be getting the percentage voltage from bus, kiloampere, real. This is imaginary as a part of kVAR. Then X by R ratio, kiloampere. That is the fault current magnitude at bus 1, bus 3, power grid, bus 2, etc. Okay, from bus to bus. Bus 1, like that it is showing, right? Okay, then these are the different pages. And let us jump to the final, that is the summary. Okay. For each bus, the calculation is given here, right? This is about bus 1. This is about bus 1. For bus 1, what is the nominal kilowatt that we have added? Then this is voltage factor. Like this can be changed. Voltage C factor can be changed. Peak value of current, that is in kiloampere. Then steady state current. This is the value that we need. This is the fault current that we need. Okay. This one is the fault current value that we need. 13.122 kiloampere. Okay. Same like that for bus number 2. Right. This is bus number 2. 3-phase faulted bus number 2. Here we are getting how much current? This is our fault current, 15.75. Okay. Then bus number 3. How much is our fault current? 17.007. Okay, so based on this fault current, you are selecting circuit breaker, isolator, fuses for the connected feeders. This is bus number 4 and the steady state load fault current is 2.034 kiloampere. Okay. Bus number 5. Bus number 6. Bus number 7. Okay. Totally 7 number of buses are there. So for each bus, short circuit can be calculated by this method. Suppose you need only to calculate the fault current at only one bus. That is sufficient. Here I have included all the buses. So based on these fault current values, we are selecting different protective devices, relay settings, etc. For example, I need to select a circuit breaker for this load 1. Okay, so here I need for connecting from this bus number 2, that is the MDB. If this is the MDB bus bar, from connecting this MDB bus bar to my load, I need a circuit breaker. So based on this 20 kVA power or load, connected load, I will be calculating load current. I will be selecting the ampere rating of my circuit breaker. But I need to select the fault current rating of my circuit breaker based on this value, how much I am getting here, right? So what is the value at bus number 4? If it is 2.043, based on that value, I need to select here 2.113 kiloampere, right? Based on that value, I need to select a circuit breaker for here. Okay, so here it is 5.743. So based on that value, I need to select the circuit breaker for this branch. Based on this value, 10.985, I need to select the circuit breaker here. Based on 13.599, I need to select the circuit breaker short circuit current from here. Okay, like that. So for that, I'm selecting, if I'm selecting or I'm connecting a circuit breaker at the primary side, based on this fault current, I need to select it. Cable also, right? Cable also here, I need to select based on this fault current. Secondary side, based on this fault current, I need to select the cable, then circuit breaker. Okay.